We have one final scenario to explore, finding lengths of segments when we have the secant segment and the tangent segment intersecting. Now notice I try to keep the letters similar to how they were before, and the intersection of this tangent segment and this secant segment is at point E. Now the formula we can think of in terms of the other one, AE times BE equals CE times DE. However, you might be wondering, there is no point B. The other one makes sense because C and D are on that secant segment and everything has to touch the intersection point, point E in this case, but what about this tangent segment? There's only point A. So I would like for you to consider what it was like when we had two secant segments. So I'm going to draw in the other secant segment. This is E. We'll pretend this is A and B. And for now, we'll ignore the fact that EA is up there. So this is EA, the external segment, and EB, the secant segment. And our formula was AE times BE equals CE times DE from the other secant segment. Now CE and DE, or secant segment ED, DE, will remain there while we explore this secant segment. This was our formula so far for everything where the intersection point E is what everything's about. Always touch the intersection point. So AE, BE. Well, what if I move this secant segment so that it's a little bit higher in the picture? Well, that means A is now up here and B is now up here. What happens to point A and B? What happened to points A and B? Well, here they were A and B. Now they're a little bit closer together. Well, what if I do that again? I'm going to have to erase this squiggled out tangent segment so that I have room to show you. Here is another secant segment. Now here's point A and here's point B. What happened to them? They got closer together again. Now, this is kind of difficult to see when I draw it, so I'm going to show you this animation. I'm going to be able to drag point B along the circle so that it's getting closer and closer and closer to point A. Now, as I do it, you're going to see some numbers changing. This secant segment stays the same. You'll see this PC says 19.8, see up here 19.8, and PD, the entire secant segment, says 32.5. See right here, 32.5. So those get multiplied together and we see 644. The other secant segment, the external part, says 20.1, and the secant segment says 32. I'm going to move point B closer to point A. You'll see these numbers change, yet it still always equals 644, which the other one equals as well. But what you should be noticing is that point A and B, no matter how close they get to each other, we're still multiplying those two numbers together. In fact, when they land right on top of each other, we have to multiply them together. Point A and B landed on top of each other. This external segments, well, now it's a tangent segment, are exactly the same length. We don't just take one of them, we multiply them both together. So the conclusion to that is when we have a tangent segment, like in this scenario, we don't have points A and B because A and B are essentially the same point. So instead of saying AE times BE, we have AE times AE because it's the same point. So we can either write this formula as AE times AE equals, and then the other secant segment is the same that we're used to, CE times DE, or we can write it as AE squared equals CE times DE. Either way you want to think of it, I prefer to think of it like this because it's essentially the same formula we use for all segments. Let's see how it's applied. Find the value of x in each of these examples. Well, like all the other ones, I see where the intersection point is. I tell myself I have to touch that intersection point. So I have this tangent segment, it says 12. It's the only segment for this guy right here. So it gets multiplied to himself. So the way that I do that is I write 12 times 12 and then equals, And then I go over to the other segment. This guy is a secant segment. So I do the external part that's touching the intersection point that says x times. Now this time they're showing me the whole way across by putting this bracket here. So this bracket is telling me that from this endpoint to this endpoint, it says 16. So the whole secant segment is already measured for me as 16. Now we can solve this equation. 12 times 12 is 144. 16 times x is 16x. Divide both sides by 16, and I have that x equals 9. Would you like to try the other one on your own? Let's check out how you did. Here's the intersection point, so I have to touch that one every time. This one is the tangent segment. I usually start with that one. So here's the tangent segment. It gets multiplied to itself. 2x times 2x equals, now I go to the secant segment. The external part says 9 times, then I need the whole way across. This one's not given to me, so I have to figure it out. 9 and 4 put together, add it up, make 13. So times 13. Now we can solve the equation. 2x times 2x, 2 times 2 is 4, and x times x is x squared, so 4x squared equals, and then I have 9 times, oh, I just saw I wrote 19 instead of 13. Well, let's fix that immediately. 13 right there. So 13 times 9, that's 117. Have to divide by 4 first, so x squared equals, well, that doesn't divide evenly, so I'm going to write it as 117 over 4, and then we want to take the square root. So I can write it as 117 square root of 117 divided by 4, or square root of 117 divided by 2, since I can't take the square root of 117, or I take the decimal and I say x is approximately 5.4. Leave your answer however is suggested by the directions.